Hi everyone, this is Miss Tom with another video about exponential functions. Today our topic is about simple and compound interest. So let's talk about it. By the end of class, students will use what they know about linear and exponential functions to investigate simple and compound interest. So let's talk about this. When we talk about interest, we're talking about money. How much money are you going to earn if you put money in the bank? Now it's calculated two ways, simple being the simple version and compound being the slightly complicated version. Simple interest is linear, meaning it grows at the same constant rate. But compound interest is actually exponential. It grows multiplying by some sort of rate. So let's talk about principal. Principal is really what simple interest is based upon. Principal is your starting amount, and that's how simple interest is calculated. It's interest paid on the principal. So, it's what each time you earn from, and the principal is the year zero. So it starts in year zero. We see how much money did we put in the bank. In year zero, we have the principal. So let's go ahead and see if we have 3% of an initial investment of $2,500. What's that going to be? Well, I know that 2,500 is 100%. And if you want to find 1%, all we have to do is move the decimal. We've got to just move the decimal over 1, 2, right? Because 100 becomes 1 by moving the decimal over 1, 2. So we just need to do that here, 1, 2. And then we got 1% is $25. If 1% is $25, what is 3% then? 3% is triple 25, and triple 25 is 75. All right, we've got it. So we know every year we pass, we get $75 extra. So the principal amount is at year zero. How much money do we have in the bank? We've got $2,500. But every year that passes, we've got an extra $75 every time it's $75 more. So the next month is going to be $2,575. Then we're adding another 75 each time. Pause the video. Let's see if you guys can figure out the next here. Okay, so then we're going to go 2,650, adding another 75, 2,725, adding another 75, 2,800, and then lastly another 75, $2,875. So you can see, when you put your money in the bank and it has simple interest, you're earning $75 extra each time. What kind of equation is that going to be? I'm going to use T of n because that's what we have here. We have a sequence. We have values that go up by years. So we know our growth being 75 is how each time it's growing. And then we've got our n value, which is the number of years each time. And then we're going to go ahead and add our y-intercept, also known as figure 0, or what was the principal starting amount, which was 2,500. This is really helpful because what if you want to know how many dollars you have in your account after, I don't know, 10 years, 20 years. It's always good to plan ahead, and that's why That could be the potential equation. All right, let's go to the next one. Here we go. Now, this is actually the one that's commonly used. This one is the one that banks actually use, and it's called compound interest. And this is based on the interest that's paid on the previous year. So what happens is compound interest is an interest that's paid each time from the previous year. So let's go ahead and see if we can figure out what's happening here. So with the table, you're going to notice, okay, the table's growing by different amounts, but how does 2,500 become 2,575? So what I'm going to do is I'm going to use my calculator, okay? And it's okay to use calculators as long as you understand where the numbers are coming from. So how would I do this? A common mistake is to be dividing 2,500 divided by 2,575, but really we want to figure out what happened here. So I'm going to actually do year 1 and then dividing it by year 0. And we're going to get 1.03, okay? Now what does that mean? That means that this rate is being multiplied by 1.03. Now let's think about that. That means that 1.03, it's known as 103% of the previous year. So what's happening is you're getting an increase of 3% each year, but you're also including the amount of money that was before. So let's go ahead and try this out. Let's go ahead and see, is it the same amount here? 2,652.25 divided by 2,575. That's also 1.03. So this is being multiplied by 1.03 each time. So how do we write this as an explicit equation? First of all, we know T of n. Since it's exponential, meaning it is multiplied by the same amount each time, we're not going to use our linear equation. We're actually going to use our exponential equation, which we learned from last lesson was this. Remember, A was our starting amount and B is our base value of what's multiplying. So here's what we're going to notice. Noticing our value of our figure 0 was 2,500. Then we're going to multiply it by, what is our multiplier, the base that keeps multiplying? 1.03. And then we're going to call this to the n power because we don't know how many years we're going to have. So that's how we get the compound interest. In this case, I know it says 1.03, but if you were at 100% and you were increasing each time to 103%, that's actually just an increase of 3%. And so this is a 3% annual interest compounded. Alrighty, so let's go on to the next one. Okay, so we're actually going to be analyzing a real life college situation. So if you go to college, you want to invest money, right? If you get an 8% interest, oh my gosh, that would be so great if you got 8% interest. How much money are you going to have? Basically, it's going to have you analyze two situations, one of them being simple, one of them being compound. So let's take a look here at this equation. Okay, so we've got this table. First of all, what do you notice? I notice it goes from 1,000 to 1,080, so we're adding 80 each time. Okay, so how much money does it grow by with simple interest? We're going to say, and I'm going to type this out here, we're going to say the money grows by $80 each year. Now, it says, by what percent would your balance have increased by the fourth year? Well, we've got to figure out what fourth year is in the first case. So we're going to go, okay, plus another 80. That's going to be 1,320. If I add another 80 to that. And then we go, okay, how do you figure out how much you increased what balance? Well, it's just like what we did before. We're going to take year 4 and divide it by year 0. So what's that going to be? Now, I could use a calculator, but I'm going to show you a trick here. A trick meaning a mathematical idea that you can use to simplify the problem. You can divide both by 10. Those zeros get out of the way. Then you're going to go, okay, 132 divided by 100. You can know that percent means out of 100. So it was now at 132%. So if you go from 100 to 132%, then you know it did what? How much did it increase? We would say the money increased by 32%. And that's what we have. Okay, so the money increased by 32%. That's quite a large amount of money to grow, but that is what happened here. All right, so now what we're going to do is we are going to go ahead and figure out, what about compound interest? How much did compound interest grow by? So let's find out. Okay, so compound interest means that instead of adding by the same amount, we're multiplying by an amount. So let's figure out what we're multiplying by. So we know that 1,080 divided by 1,000 is going to be equal to, 1.08. That makes sense because it's compounded by 8%. So this is being multiplied by 1.08 each time. So let's see if we can figure out what year 4 would be. All right, let's figure out what's year 4. So I'm going to go 1,259.71 times 1.08. We get 1,360 and 48. Okay, so we'll write that. 1,360 point and then 48. Yep. So the question asks, how is it growing? Why is there this amount? Then we're going to write down, how is it growing? Well, we know it is growing by multiplying by 1.08 each year. And what will be the balance at the end of the fourth year, and by what did it increase? So we already figured out that it would be 1,360 and 48 cents. But let's go ahead and figure out, well, if we take that and we divide it by the initial starting amount, which was 1,000, we're going to get 1,000 or 1.36. So we're going to say, okay, 1.36 translates to 136%. So how much did the balance increase by? We're going to say the balance increased by 36%. And there we have it. That's how we figure out how much it's increasing by. So this was a very quick lesson on compound interest and simple interest. What I'd like you to do is I want you to practice them by doing these sequence problems on your own, and then answer the closure question for today, which is this one here. Which one grows faster, compound or simple interest? Thanks for watching, everybody, and I'll see you next time.